All right, let's talk about the secret language that's running pretty much the entire digital world around you, SQL. It is the invisible force behind so many apps we use every day. And by the end of this, you're going to totally get how it all works. So, let's pull back the curtain.
I mean, have you ever really stopped to think about that? Every time you log in, every time you save a preference, every single purchase you make, massive amounts of data are flying around, being stored, and then pulled back up in an instant. How in the world does that not just descend into total chaos?
Well, it turns out there's a reason it all works so smoothly. All of these different, complex systems, they have a common ground, a shared language that lets them talk to their data with perfect clarity.
And that language is SQL. It stands for Structured Query Language. You'll hear people say SQL, you'll hear them say SQL. Both are totally fine. It's the universal standard for communicating with relational databases, which, are just these super organized databases that store information in tables. Think of them like spreadsheets on steroids.
So, here's our game plan. We're going to cover what this language of data is all about. Then, we'll learn how to draw up the blueprints for our data. After that, we'll see how to actually bring that data to life. And finally, the really cool part, how to ask questions and get answers from it.
First up, Data Definition Language, or DDL for short. I want you to think of this as being the architect. Before you can put anything anywhere, you have to design and build the house, right? Well, DDL commands are what we use to build the very foundation of our data universe.
And in our Architect's Toolkit, we've basically got 4 main tools. Create lets us build new things, like tables. Alter is for when we need to renovate or change something we already built. And then we've got 2 ways to tear things down. Drop is the wrecking ball. It demolishes the entire structure. Truncate is more like a deep clean. It empties everything out but leaves the structure standing.
So, before we can store any data, we need a container for it. And in SQL, that container is usually a table. We build it with the create table command. It's simple. You just give the table a name, and then you define all the columns that are going to be in it, telling SQL what kind of data each column will hold. Like, is it a number? Is it text? Is it a date?
Let's look at a real example. See? We're saying create table and calling it persons. Then we're defining the columns. Person ID is an int. That just means integer, a whole number. And last name and first name are varchar 255. That's just a fancy database way of saying this column holds text up to 255 characters long.
And boom, just like that, our blueprint is now a real thing. We have this perfectly structured table called persons. It's totally empty, but it's there, and it's ready for us to start adding data. We've officially built the container.
Now, before we move on, this is a really important point. If we use drop table persons, the whole thing would just vanish. The structure, the columns, the name, gone forever. But if we use truncate table, all the data inside would get deleted, but the empty table, the structure itself, would still be there. It's a huge difference. Okay, so our structures are built, our house is ready, but an empty database isn't much fun, is it? So now it's time to actually move our data in and bring this whole thing to life. And for that, we need a different set of tools, the Data Manipulation Language, or DML. The 3 big players in DML are insert, update, and delete. And honestly, their names tell you exactly what they do. We use insert to add new data, update to change existing data, and delete to get rid of data we don't need anymore. This is how our data actually becomes a living, breathing thing.
So here's an insert command in action. We're telling the database, hey, insert a new row into the student table, and here are the values. Then we just list them in order: a registration number, a name, a birthday, and a mark. 1 command, and a new student record is created. Simple as that.
But wait, what if we made a mistake? What if Monty's mark was actually 50? No problem. We just use update. This command says to set the mark column to 50, but, and this is the most important part, look at the where clause. That tells the database which record to change. Without that, we would have just changed every single student's mark to 50. So that where clause is your safety net.
And it's the exact same story with delete. Let's say a student leaves the school. We can delete them from the student table. But again, that where clause is absolutely critical. It makes sure we only remove the student with that specific registration number. If you forget that where clause, you could accidentally delete everyone. Yikes. Okay, we've built our world and we've populated it with data. Now for the best part.
Now we get to ask it questions. This is where data query language, or DQL, comes in. This is how we find information and uncover insights, and it's really the whole reason SQL is so incredibly powerful.
So, let's play with this simple little student data set. We've got 3 students, each with their info. Nothing too complicated. Now, let's see what we can find out.
The absolute superstar of DQL is the select command. It's how we ask our questions. And the structure is so logical. Select is what you want to see. From is which table you want to look in. And where is the filter, the condition the data has to meet. So here, we're literally asking, select the names from the student table where the mark is exactly 70.
And would you look at that? The database instantly scans the table, finds the 2 students who match our criteria, and gives us back only their names. A perfect, precise answer in milliseconds. That's the magic right there.
But SQL can get even smarter. What if we want to find a pattern, not an exact match? We can use the like operator. That little % is a wildcard. It basically means, and then any other characters. So this query is asking for every name that starts with the letter A.
And once again, SQL nails it. It finds both Anand and Abhishek and shows us their names. This kind of pattern matching is a real game changer when you're searching through lots and lots of text data. So let's just do a super quick recap of the 3 pillars we've talked about. We started with DDL, the data definition language, to be the architect and create our structures. Then we used DML, the data manipulation language, to insert and update the actual data. And finally, we used DQL, the data query language, with select to ask questions and find answers. Define, manipulate, and query.
Look, we have only just scratched the surface today, but you now have the fundamental grammar of the language that brings order to the digital universe. You have the power to not just store information, but to actually talk to it, to ask it questions, to learn from it. So that really just leaves one last question for you. Now that you know the language, what questions would you ask?